Okay, this video will be on adding and subtracting fractions. Still, Unit 2. When you're adding and subtracting fractions, you need to find the lowest common multiple if the denominators are different. Would have been nice if I would have put that in the first place. So yes, find the lowest common multiple or the lowest common, I forget what else they call it, LCD, lowest common denominator. If the denominators are different. If they're the same, then you just add or subtract as normal. Number 2, you need to rename each fraction with its new denominator. Number 3, you'll add or subtract the numerator only. You leave the denominator the same. And then you simplify. Let's practice. So I taught the students the 4-square method. In the first square, you write your problem. So here we have 2/3 plus 3/4. And our denominators are indeed different. So I'm going to write a 3 here and a 4 here. And then I'm going to write all the multiples of 3. Like 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Okay, then I'll come down here and do the same to 4. 4 times 1 is 2, 4 times 2 is 8. Well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and then we have our lowest common denominator. So then we come down here, and our new denominator is going to be 12. So, and then whatever we do to the denominator, like how did we get 12 here? Well, we multiplied it by 4. So we're going to have to do this to our numerator. So 2 times 4 is 8. How did we get 12 here? We multiplied by 3. So I'm going to have to multiply by 3 here. So 9. So I renamed my fractions here. And in the 4th square, I'm going to go ahead and solve. So 8 plus, I'm just going to add the numerators, just numerators. Keep the denominator the same. So 8 plus 9 is 16, 17. So I have 17 12s. And then I need to simplify because this is an improper fraction. So 12 will go into 17 one time with 5 left over and 12 over our remainder, our denominator. Let's subtract 1. Okay, here we have our denominators are different again. So I'm going to come up here. Then I'm going to list the multiples of 8. 8 times 1 is 8. 8 times 2 is 16. Times 3 is 24. Times 4 is 32. I'm going to come down here and do the same with 12. 12 times 1 is 12. 12 times 2 is 24. And here we have a match. So my denominator is going to be 24. Okay, and then I need to come up here. How did I get 24? What did I multiply 8 by to get 24? I multiplied it by 3, so I have to do that to the numerator as well. So 5 times 3 is 15. How did I get 24 here? I multiplied it by 2. So I have to multiply my numerator by 2 as well. So then I have 2. I renamed my fractions. And then I solved. 15 minus 2 is 13 over 24. And that's my answer. It cannot be simplified. Mixed numbers can be added and subtracted too. First of all, let's go in. What is a mixed number versus an improper fraction? A mixed number is a number that has a whole number and a fraction. An improper fraction would be just like we saw. It was 17 over 12. Our numerator is greater than our denominator. Just our numerator and our denominator. Yeah, that's the denominator. I know, I spelled it. It went off the page. Denominator. Forgive me. And then usually with an improper fraction, we have to simplify, and we just divide 17 divided by 12. And 12 will go into 17 one time with our remainder, and then our remainder goes as our numerator, and our 12 is our denominator. That's how we simplify that. All right, let's add mixed numbers. and we have the same denominator, so I don't need this box here. But whenever I'm adding mixed numbers, I like to stack them like this. And then I just add. So I have 1/5 and 3/5, which equals 4/5, because we just add the denominator. I mean numerator. No, numerator. Add the numerator, not the denominator. And then we have our whole numbers and we add those together. And so our answer is 3 4/5. All right, let's subtract. As you can see here, our denominators are different, so we need to find a common denominator. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So 3 times 1 is 3, 3 times 2 is 6, 9, 12, and 15. So our denominator is going to be 15. Something over 15. What did I multiply this by to get 15? I multiplied it by 3, so I have to do it to the numerator as well. So that'll be 6. What did I multiply to get 15? I multiplied by 5, so I have to multiply the numerator by 5 as well. So 1 times 5 is 5. And then I subtract as usual. Only the numerators. 6 minus 5. 6 minus 5 is 1. Our denominator stays the same. 2 minus 1 is 1. So our answer is 1 1/15. And of course that cannot be reduced. All right, sometimes you will need to regroup when subtracting fractions. For instance, we have 1 and 2/7. So what do we need to change this 1 in? We need to change this 1 into a fraction. So any number over itself will equal 1. So I am just going to rewrite, we're not going to need this, I'm just going to rewrite 1 as 7 over 7 minus 2/7. The reason that works is because 7 divided by 7 is 1. Even if we had 100, if 100 over 100, that still equals 1. Because 100 divided by 100 equals 1. So that's why 7 over 7 equals 1. And so then I can just continue to subtract. So 7 minus 2 is 5. And then keep our denominator the same, 5/7. Let's do another one. Okay, here we have 2. So how can I write 2 as a fraction with the denominator of 10? So it would be an improper fraction. It would be 20, because 10 will go into 20 2 times. So we have 20 divided by 10. 10 will go into 20 2 times. Minus 3/10. So 20 minus 3 is 17/10. Here I have an improper fraction. So I'm going to simplify. 10 will go into 17, or 17 divided by 10, 1 time, with 7 left over, and then I put my remainder over my denominator. So our answer is 1 7/10. All right, let's do this one. So here, I want to, our denominators are the same. So I'm going to write 2 1/4 minus 3/4. But as you can see, we cannot take 3/4 away from 1/4. So I'm going to borrow 1 whole from the whole number. Then I'm going to add 4/4, because I borrowed 1 whole. 4/4 equals 1. So now I'm going to add these two together. And so now I have 5/4. I have 1, because I still have this whole number right here. I have 1 5/4 minus 3/4. Because if we have 1 5/4, that still equals 2 1/4. So, okay, here's my new problem right here. A new problem. So now I can take 3/4 away from 5/4, and that will give me 2/4. And then I just bring my whole number down. So then I have 1 2/4 2/4 can be reduced by dividing each of these by 2, the numerator and the denominator by 2, and that will give me 1 and 1/2. All right, one more. Here, our denominators are different, but I know that 3 will go into 6. So I am only going to change the bottom mixed number here, so -1. So I know I'm going to have a 6 here. So what did I multiply 3 by to get 6? I multiplied it by 2, so I have to multiply my numerator by 2 as well, and that will give me 4. Alright, I can't take 4/6 away from 1/6, so I'm going to have to borrow. So that'll give me a 4 here. And since I did a whole, I'm going to add a whole to this fraction, and that will give me 7/6. So now I have 4 and 7/6 minus 1 and 4/6. Because once again, 4 and 7/6 equals 5 and, let me reset. 5 and 1/6, right? Yes, that's it, correct. Okay. And now I can take 4/6 away from 7/6, and that will give me 3/6. And then I have to subtract my whole numbers. 4 minus 1 is 3. So then I have 3 and 3/6, but 3/6 can be reduced by dividing that by 3 and dividing that by 3. We get 1/2. So we have 3 and 1/2 as our answer. And that's it. Thank you.